We've learned to identify what a monatomic ion is. Now we need to learn how to name them. So monoatomic cations are named using the element name plus the word ion. So Mg2+, this is a monatomic cation, it's just called magnesium ion. These guys are the nice, easy ones. Most of the main group elements, the main group metals, only form one cation. And so they are predictable from the periodic table. We looked at those already. Group 1 forms +1, group 2 forms +2, group 3 forms +3. But those transition metals, the part in the middle of the periodic table, those guys are harder to predict what their charge is, and many of them form 2 or more different ions. And so you can get iron with a +2 charge and iron with a +3 charge. And you can't predict what those charges are from the periodic table. So for those guys, we have to specify the charge when we're writing the name, because it could be one of 2 or 3. And the only way you can communicate with someone else is to write down what the charge is. There's 2 ways of doing this. Thank you, my arrow was stuck there. Now my arrow doesn't work at all. I'm pointing, there we go. The stock system uses Roman numerals. This is the preferred system and the one that we're going to use in class, and this is the one you need to know. I'm just going to tell you that this other one exists because you'll see it occasionally, and I don't want you to be, wonder, what on earth is that? It's the Latin system, and it uses the Latin element names and us or ic suffixes. And so you'll see things like ferrous chloride or ferric chloride, and that's iron 2 chloride and iron 3 chloride. This system is much harder to remember, and it's older, and we're trying to kind of phase it out, and so we're going to focus on learning the stock system. In the stock system, the ion charge is specified with a Roman numeral in parentheses after the element name, followed by the word ion. So Fe3+, Fe is iron. Iron, if we find it on the periodic table, is not in group 1, 2, or 3, right? It does not have a predictable charge. And so we need a Roman numeral, and so we put the Roman numeral 3 in parentheses to specify that this is iron 3+. We don't put a space between these. It's just tagged right onto the element name. Then there's a space and the word ion. And just in case you're a little rusty on your Roman numerals, let's talk about those. So we need 1, 2, 3, 4, 5, 6 is probably high enough. Roman numeral 1 is a capital I. Roman numeral 2 is 2 capital I's. Roman numeral 3 is 3 capital I's. You can imagine that if we went on like this, what's the difference between this and tally marks or something, right? It's just a bunch of I's. Well, 5 is a capital V. Because 4 is 1 less than 5, 4 is I before V. It's 1 before 5. And 6 is 1 after 5. Can you imagine trying to do math using numbers like this? It doesn't sound very nice. But then again, they didn't have, long addition and multiplication. They used an abacus. So that kind of tells you something about the Romans. Anyway, so those are the Roman numerals. Which ones need Roman numerals? Well, it's best to remember the ones that do not need Roman numerals. In chemistry, we try to be efficient and not write a lot of stuff out that we don't need to. We're not going to call iron 3+, it's the, 1, 2, 3, 4. It's the 6th element in the 4th row of the periodic table, and it lost 3 electrons as its name, right? That's going to be really long and tedious. So we only use the Roman numerals if we need to. The metals in groups 1A, 2A, 3A, plus these 3 guys, only form 1 ion. Because they only form 1 ion, they're predictable. All we need is the periodic table to see what their charge is. We're not going to write a Roman numeral. if you write a Roman numeral where you're not supposed to, it's going to be marked incorrect. So you remember this, groups 1A, 2A, 3, zinc, silver, and cadmium. That's a short list, right? You can remember that. All the other metals need Roman numerals. So let's look at this chart here. So here we have group 1A. These do not need Roman numerals because they're all +1. Group 2A, all +2. Group 3A, these are +3. And then here's the 3 oddballs. Now what's kind of cool about these guys, let's see if I can do this without making too much of a mess. They form a triangle. It's kind of, maybe it's like the Bermuda Triangle or something. There's a triangle in here. And this is how I think of it. So aluminum and gallium and indium are all +3. And then we go over here, and these are +2. There's 3 of these, they're +3. There's 2 of these, they're +2. There's 1 of these, it's +1. We're going down the stairs, 3, 2, 1. So these 3 guys here, you need to memorize. Zinc and cadmium are +2. Silver is always +1. Okay? But that triangle, you get that firmly in your head, you can remember it that way. And then this is also just showing you the charges that these anions have. Oh, it drew it for me. How nice. There was an animation hiding in there. To name the nonmetal ions, the nonmetals gain electrons, they form anions. We take the element name and change the ending to "ide," and then add the word ion. So Br minus, Br is bromine. We change the ending to bromide. Fluorine becomes fluoride. And just like there's no flour in fluorine, there's no flour in fluoride either. It's UO. Oxygen becomes oxide. Phosphorus, phosphide. The charges are known from their position on the periodic table. So we just learned about naming these ions. If we're given the name, though, we need to be able to write the formula. When we write ion formulas, we write the element symbol with the charge as a superscript on the right. And we always write the sign, which is different than in math. In math, if you have an exponent that's positive, you don't put a plus, right? There's another mistake. We always write the sign, even if it's positive, and it's written after the number. And that's different than what we do with exponents in math, right? Like x to the -2, right? Or we would have x squared. Those are math superscripts. They mean exponents multiplying. Chemistry, let's make these blue. Chemistry, you might have sodium plus. I don't write the, I'm skipping ahead. We don't write the number 1. Chemists seem to have a thing against the number 1. I think we're really just being efficient. We don't write the 1 if we don't need to. So sodium plus, magnesium 2 plus. We write the sign after. In math, you don't write the sign if it's positive. In chemistry on ions, you do. And for a negative, you might have iodide ion with a -1 charge, or you might have nitrogen with a 3- charge. The sign comes after. For ions in groups 1A, 2A, and 3A, because we're talking about cations here, the charges found from the periodic table, zinc, silver, and cadmium need to be memorized. And I just showed you how to do that. The other monoatomic cations are going to have a Roman numeral, and so it's going to tell you what the charge is. Let's predict the formulas for these monatomic cations. barium ion? Well, first we need the symbol for barium. Ba, right? Ba, and we find it on the periodic table. What group is it in? It's in group 2A. That tells us that the charge is 2 plus. Group 2A, 2 plus charge. How about cobalt 2 ion? What's the symbol for cobalt? CO. Make sure that's a lowercase o. What does this Roman numeral 2 mean? It's the charge. Because where's cobalt? It's not in group 1, 2, 3, zinc, silver, or cadmium. It needs a Roman numeral because it can form more than one kind of ion. So this Roman numeral tells us what the charge is. It's 2 plus. How about aluminum ion? It's in group 3A, it's Al. Group 3A, 3 plus. How about zinc ion? Well, it's not in group 1, 2, or 3, but it's in that triangle, isn't it? What's the charge on zinc ion? 2 plus. So zinc, 2 plus. Any questions? Does that make sense? For the monatomic anions, these form anions by gaining electrons. And like I showed you, we can predict the charges by counting backwards from the noble gas group until you get to the element you need. So it works out that group 7A ions have a -1 charge, group 6A have a -2, and group 5A have a -3. If you don't like the counting on the periodic table, there's another way you can do it. You can take the group number -8. So group 7A would be 7 minus 8. The charge will be -1. Group 5A will be 5 minus 8, which is -3. So some students like that method, but most of them don't. So let's do some examples. What is the formula for these ions? Sulfide ion. What's the formula for that? S. So its sulfide comes from sulfur with the symbol S, and then the charge on sulfur is -2. So I write 2 minus. How about phosphide ion? Phosphorus is P. It'd be 3 negative. These are nonmetals. Nonmetals form negative ions, always. Oh, this one's interesting. How about hydride ion? This would be H minus. See, on that periodic table, on that side of the classroom, hydrogen shows up in 2 places, right? Because hydrogen can form a negative ion and act like the group 7A elements. It can also form a +1 ion and act like the group 1A elements. He's pretty squirrely.